Okay, today we'll continue with the Spades project. Although the project is finished, we can improve the project in more than one way. One possible way of improving it is actually the interface and some small minor details. So the first thing we will do is we actually print the suite characters. So in order to print suite characters, you need to know the Unicode of the clubs, hearts, diamonds, and spades. You can look at from the internet, and we actually found it like this. And then instead of C for clubs, H for hearts, D for diamonds, and S for spades, you see we replaced them with like this. So let's run the program again and see the difference actually. So let's enter our name, Olcay, and then 0. And you see there are now characters, card suite characters displayed. So we have 5 clubs and 5 diamonds, excuse me, 2 clubs, and then 1 heart, and then 5 spades, etc., etc. So the first thing we have done that. The second thing is in the comparison. So in the comparison, we have written a large code so to compare the suites actually. So actually in the enum classes, there is the compare to method, which actually compares the enum values. So in that case, we can easily compare with card 1 get suite and then card 2 get suite. In this case, for the this compare is utilized as we remember to compare to sort actually the characters in our hand, and in that case the spades will be the largest one. So for that reason we actually put a minus here, because in the enumerated type the spade is actually the lowest one. So that's actually, we put a minus here. And then other than that, we also write a compare only ranks method, because we use them in 2 places. The first is in the compare to method. So, and the second is this compare method. So therefore we have written a compare only ranks method, which only compare, as the name implies, the ranks of 2 cards. So if the cards have the same suite, then we check if the first card rank is 1 for ace. If it is that, it's better. If the second one is ace, then the second one is better. Other than that, we compare actually the values of the cards. So those are actually the modifications we have done on the card class to make things, let's say, a little bit smoother. Okay, so other than that, today we will basically talk about the AI, so the computer player. As we remember, the computer players, there are 2 things to consider in computer player. The first one is in the bidding stage, and our program does bidding something like this. If the sum of the ranks of the hand is less than 104, then he or she bids 1, and other than that, he or she bids sum minus 104 divided by 4. We actually created this dummy formula just for making in general a bid. So if this, we expect here that if the sum of the ranks is getting larger and larger, then we can do better and better, etc., etc. And the second thing is there is the play card, which in that case, this dummy computer player plays just randomly. So it randomly selects a card from its hand and then just randomly puts it. But the thing is, if the card is against the rules, then in that case, we need to randomly get another card. So that's why actually we have a while loop here to check if the card is correct or not. So these are actually for the dummy computer player. So in that case, let's create a second player, let's say a little bit then better. So in that case, we will create actually 2 classes. The first one is dummy computer player. And then we also create a new class, which is average computer player. So which is actually better, we hope, than the computer player. Both of them should extend the computer player, and then average computer player should also extend computer player. So also for the computer player, we will actually remove this make bit and play card and then put them actually in the dummy computer player. So in the dummy computer player, we put it like that. And then for the computer player, we should also put a empty constructor. So let's say computer player, and then the super, and then computer. Okay, so other than that, we should also make the computer player abstract. And then we have two main problems. We have the average computer player, which actually needs to have this. So let's put them here. Average computer player. We need to implement methods. So let's implement them, make bit. And then the dummy computer player is okay. The computer player is like that. We have only one related problem here. Let's make this player the dummy computer player. So in that case, the dummy computer player will be something like dummy computer one. So in that case, we should also go to dummy computer player to add an extra, let's say, something like this. So let's make it like this. In that case, let's make it, okay, dummy. And then we have the dummy computer player. For the average computer player, we can also put again an basic thing, and the computer player now we don't need to utilize actually. So that's actually something like this. So we can do like this, and then if we have that, okay, super, we have the problem. So let's put a name here. Okay. So we have the new dummy computer player, and then we have also the average computer player. So now we will concentrate on basically the average computer player. So how will we make a bit for the average computer player? So if we play, if you know this trick winning games, so in general, the card distribution is important. So we have 4 players. For each suite, we have 13 different, let's say, cards. So in that case, what are the possibilities of the distribution of the cards? One standard distribution is something like this. So 3, 3, 3, and 4. So 3 players will get 3 cards and 1 player will get 4 cards. So in this case, 1 player can win with 3 winning things, which are actually ace, king, and queen. So the queen can win actually if anybody, at least every player has 3 cards. But if an only player has 2 cards, in that case, the queen cannot win because the 2 card having player may actually break the suit and play spade. So in that case, in order we can play safe, and then we can just count the number of aces and kings for each suite. And who will count those cards? Actually, the hand. So let's put it here. Let's write a function, count winning card. So in that case, it will return us the winning cards. So then let's only count the ace and king. So you can also modify the count winning cards to include queens, but okay, so as we have said, this is only one chance. So in this case, we don't want to be that liberal. So okay, so if hand get I, which is card, is get rank is 1, which is ace, or if the rank is actually king, which is 13. So in that case, we increment the count. So count is 0, and then we have count plus plus, and then we return count. So in this case, remember that we are also counting actually. So let's make it with enhanced form. So remember that we are actually talking about also spades in counting. So we also count spades, cards, ace, and king. Although we can break the seat and win some cards, but the thing is that only works for small suites or small number, or let's say short suites. So we can also do that, but the thing is, let's continue slowly. So then in that case, we will actually return two things. Return count, actually hand count winning cards. So that's actually will return us the make bid. And we can also count actually short suites. So if we have only 1 or 0 actually from a 1 suite, then we can actually maybe win extra card for that. So for 2, if we have a short suite, which means less than 3 or less than 1 or 0, not less than 2, 1 or 0, then we can have an extra. So in that case, let's write a short suite. So integer short suite count. So we will count for each suite except spades if we have only 1 card for that suite. If we only have 1 card for that suite, then we will increment the count. Okay, it's so improbable that we have actually 2 short suites, but the thing is, it's probable. So in that case, let's count them. So count is 0. So we need to count for every suite. So it means we can safely assume that the cards are sorted with respect to suites. So in that case, we can just go and check one by one. So, okay, for integer, I equals 0, I less than hand size, I plus plus. So let's say suite current equal hand get 0 get suite. So we get the first suite, and then we start from 1. If the hand get I get suite not equals current suite. So in that case, we change the current to new suite. And then we can also have something like card count for suite, which starts actually with 1 here. So if it doesn't have, then you can write card count for suite equals 1. So in that case, if the card count for suite is 1 or 0, so in this case, we should also check how many suites you have, so that you need to know, for example, for 1 suite, you may not have any cards. So there are different type of possibilities. Okay, which one we will do actually? Okay, so let's not do that. There are different alternatives to implementation. Let's do something like this. Okay, so let's count for suites. So actually contains suite. So we can actually modify this contains suite like this. We can have integer suite count, which could be a private method. And then if you consider a followed suite, you have count plus plus, which is actually something like this. So we count the suites for that card, and then we return the count. So in that case, if we can modify the contain suite like this, although it will be a little bit slow, but it doesn't matter. Returns suite count followed suite larger than 0. So that's actually modified contain suite. So if the suite count of that suite is larger than 0, then we have a contain suite. Okay. So short suite count. So in that case, we will do if contain suite clubs is less than or equal 1, then count plus plus. Actually, not contain suite. So suite count. If clubs less than 1, we increment it, or if it is less than 4 diamonds, and we also have the hearts. So then we return count. So if the number of clubs you have is less than 1, you increment by 1, less than or equal 1, you increment by 1, etc., etc. That's actually the short suite count, and then we expect that the number of for each short suite, then we can get let's say at least 1. So we also expect here our number of spades are larger than our short suite count. So we can also we can do something like this. If the suite count spades is less than count. So in that case, because in that case, we can return count minus suite count spades. So let's say we have 2 short suites, but we have only 1 spade, so we can only win 1. So otherwise, we just return the count. Okay, so that's actually a very special case. So which actually maybe we don't need to consider at all. So let's check if we have only 1 club, 1 diamond. We have 2 here. And in that case, we need to have a lot of hearts, but no spades, which is almost improbable. So, okay. So then let's go to average computer player. So for the computer player, we remove this random here. So for the average computer player, we can do also hand short suite count. Okay. And short suite count. That's all. So can we win more? Yes, we can win more for the spades, but the thing is they also have the spades. So in that case, let's finish it here. So let's put the dummy computer players. Let's also modify the play card. So how do we write a play card for an average computer player? An average computer player plays what he or it actually needs to count cards so that it can know, okay, without counting cards, let's say, let's do not count the cards, but it should play something like this. It should check if the current card, okay, if it has a winning card, which means an ace or king, it should also wait if it has an ace, it can play an ace. If it doesn't have any ace, then it should wait the king. actually the ace to appear, and then it can play its ace. So everything is actually based on counting cards. So let's for the average competitive player write a counting cards method. So how will we count the cards? Basically, we need to have actually an double array. So which means actually for each suite you have 13 cards, and when the player actually plays a card, we should actually also know if the player is an average computer player. We should be informed that that card is played. So in that case, let's write the player inform player. So inform player means the player will be informed by the game that that card is played. So let's abstract void card played. So then the player can do anything with its own strategy to modify its, let's say, its strategy, etc., etc. So in that case, card plate is that, and then we can also give actually the player index. So the player index will be something like this. This player index is actually the index of the card, or let's say index of card. So index of card means index of card for that turn. So the 0th card, the first card, the second card, etc., etc. So we give information like this to each player. Okay, now the first card is played with this, the second card played is this, the third card played is this, or the fourth card played is this. Actually, the fourth card does not give any extra information because we know the result, but the thing is every player should be informed what the card is played, so that the player, by getting that information, it can actually create its own strategy. So then let's implement these methods for the human player. We should implement actually for the human. We don't do anything at all. The human does not have any strategy for that because it actually should know what is going on. So for the dummy computer player, it doesn't have any strategy at all. So therefore, it also doesn't do anything for the card plate. But the average computer player should have a strategy. So then let's say, let's put it here, card plate. And then we also, okay, so that's all. We will fill this part, but also we should call this. So in the game, when, so as you see, we have dummy computer plus J. Okay, so dummy computer player. So we have a problem here. So expected 0. So where is the dummy computer player's name? So we don't have that. So let's put a name for that. So dummy computer player. Oh, dummy plus name. So that's all. Let's also make this for average computer player. Average plus name. So in that case, we have in the game something like this. Okay. So it will put a dummy in front of it, or average in front of it. Okay, so let's go back to the play stage. So when a card is played, actually we should inform every player. So which means in the play turn, when the first card is played with the single play, we should inform every player with that information. So in that case, let's put it here. So for integer I equals 0, I goes to 4, I plus plus, players, I card played, and we should also know which card is played. So then in that case, we cannot know here, which means we can do it not here, but here. So card played, 0 winner card. And then we also put something here. We need to put something like J because we have that J and J plus 1. And that should be played card. Okay, so we inform the player with that. We can write, let's say, inform or something like that. That's also possible. Let's write a function so that we can know what is going on. Inform players. And then let's write this there. And card plate. So card plate. We inform players. So also we need to know index of card. So it should be given like this. So inform players, 0 winner card. And then inform players, J plus 1, no, I plus 1, and not winner card, but played card. Okay, so we inform the players which card is played, and then we get the follow suite, etc., etc. So that's actually what we do normally. So then that's all. So let's go to what? Let's check actually what is going on. Is it okay or not until now? So we have Oljai, we have 0, and let's bid 3, something like this. And then we can play actually, where we play with 0. Dummy computer 2 has win because he placed an ace. Okay, so it's going something like good. Okay, so for the average computer player, when the card is played, it should know what is going on. So now we should count the cards. So let's write a Boolean array, cards played, equals new Boolean 4 to 14. Okay, so we should also initialize this cards plate for every, let's say, starting of the game. So which means we should also give info to each player that they should actually start doing their preparation. So after the deck is set, so which means in actually play hand. So when the players initialize their hand, so in that case, we have initialize hand here. When they initialize their hands, we will also, here you see, we have the hand. Then what happens is the deck deals all players, and then they sort their cards. So when they actually sort their cards, we can actually update. We actually have two things to consider. When we get new cards and then sort our cards, then the average computer player should count his or her card so that they will be put as played. And then that's actually should be done. Or another possibility is we do that later. But the thing is, the good thing is when you sort cards, actually, we know that the cards are changed. So in that case, we can do something like this. We can overwrite the sort card method. And then after it is sorted, we can actually do the thing about the card counting. Okay, so let's overwrite the sort cards. So we actually sort the cards, and then for each card we have, so I goes to hand size, I plus plus, we actually update the cards played. So first of all, we should do something like this. Cards played equals new boolean. So we initialize all cards to be played are false. And then we actually, or we can write something like super sort cards. So then what can we do is we can, for each card to be in the hand, we update the cards played. So then how will we do that? We will do something like this. Cards played. Actually, let's get the card first. Card equal hand. Get card I, and card get suite ordinal. It will return us the index of the card, and then we can actually get the rank of the card, and then we can set it to true. So the ordinal suite, which is actually 0 for the spades, 1 for hearts, 2 for clubs, etc., etc., we actually do that here, and then we also get card rank here, and we set it here. So other than that, when the card is played, we also can do it here to update it. So we know now which cards are actually played. So when we know which cards are played, then we can actually play card a little bit, let's say, ingenious. So how will we do it? We need to check if we have actually a winning card for that suite. And if we have a winning card for that suite, we will play that card. If we are following a suite. The thing is, we also should be careful if they played a spade. So that's also a little bit complex. So we have a lot of implementations here. So let's go one by one. So first of all, we need to play. So first of all, let's put the dummy computer player play cards here, so that we will be sure that it's okay. Okay. So then let's go to game and change our players to average players. So let's first check if we had done the winning case, bidding case. Okay. So let's run it and check the bidding stage. So we have Olcay, the index is 0. Okay, we have the problem. So we have the ordinal problem here. Let's check the ordinal from 0 to max value. So the ranks, I think, are from 1 to 13, if we remember. Yes, 1 to 13. So in that case, we should subtract 1 here. That's we missed. So let's run again. Okay. So that's all. So let's bid something like 1 and see what they did bid. So for example, the player's 3's bid is 0. Why? Because he doesn't have any king or ace. The player 2's bid is 2 because it has 2 kings. The player 3's bid is 1 because it has, okay, every ace is in your hand. So it's interesting. So normally it is not it's a very good sign. We can bid a lot. So let's do it again. So let's bid 2 and see we have 2 for the player 4, 2 for the player 3, 1 for the player 2. So do we have short suites? No, we don't have. So in that case, as you see, the numbers are small. So for our case, what we should do is we should do 1, 2, 3. But we also need to consider, for example, we have a diamond here, but we don't have the second diamond. In that case, we cannot win with this king. So that's actually okay. So we know we have a short suit there. So in that case, that's okay. So against us, but we should also consider that. But the thing is, in overall, the number is 7. So average player is average. Okay. So let's play something. How will it play? So it will play, let's bid 3. Oh, 4. Let's play 0. And average computer 3 will win because it placed a king there. So, okay, so let's first do something easy. So if we have a winner card, so let's do something like this. We have the followed suit, and we know if the suit is broken or not. So when the card is played, so let's first think easy things first. So let's say we have the followed suit and we are playing. So which cards have been played? We know from card played. So in that case, we should, if we have a larger rank number for that suite, we can put it. It is if it is ace or queen, ace of king. If it is not, we should go down. But that's actually not so easy. So let's then go that. So first of all, we have card plate. So we have that card. And we know for each index of the card, if it is 1, we start again, etc. So first we need to know which cards we have for the followed suite. So in that case, we should write in the hand a method which returns all the cards we have for that suite. So let's write a method for that. So array list of cards. So get cards for suite. So we have the suite, we have the suite. So array list of cards list, let's say new array list. So then we return the list. So we go over the hand for integer I equals 0. I goes to hand size. And in that case, if the okay, so we will do something like this. Card, hand. Okay, if the card suite equals suite, then we add to the list add card. Okay, we return the list. And then what we will do is we will check which cards we have for that suite. So let's get that. And the good thing is the cards will be sorted. So cards, suite cards. We have and get cards for suite. Also, let's get or spade cards. Spade cards and get cards for suite spades. Okay, so we know now which cards we have for the followed suite, which cards we have for the spade cards. So now we also should know which suite we have a winning card. So, okay, so in that case, we need to check if our best suite card is a winner card for followed suite. So how will we check it? We should write an extra method. Boolean is card winner for suite. So in that case, we have our suite cards. And then actually we don't need to give it because we need to give only the card, best card. So actually, do we need other cards in our case? Yes, we may. Okay. So we then, okay. So we check if the cards plate, we check the cards plate. And if our best card is better, current best, let's say, then we can say it is a winner. So then what will we do? We will check from the ace first. So what will we do? If our best card rank is 1, then it is a winner card because it's not played actually. And if it is not, in that case, we check if the cards played best card suite ordinal 0 is not played. If it is played, then if it is not played, okay, so if nobody played ace before, so in that case, if nobody played ace before, or if if nobody placed an ace before, which means in that case, or chance will be false because he or she can place an ace. So then if somebody has placed an ace and we don't have any ace, then we should check the other cards. So which means we should start from the last played card, so that if our card is better than the best card not played, then we will return true. So which means we will do something like this. For integer, I equal 12. And then I is larger than 0, I minus minus. And then if actually we should check not from 12, we should check actually until our card. So which means get rank. Okay, in our case, the rank is 1 to 13. So let's do something like this. So it will be like this. So if we have king, for example, we don't need to check king. But if we have the queen, so in that case, our rank is 13, and we need to check if the cards played. If not cards played, best card suite ordinal, and I, then we return false. So other than that, we return true. Okay, so what did we do here? We check if our card is an ace. If it is an ace, then our card is a winner for that suite. If it is not, we check if the ace is played or not. If the ace is placed, also we need to do something like -1 here. So if it is not played the ace, then it can be a chance that the player can place the ace. So we need a false. So we don't have an ace, or ace is played. So in that case, we check if the cards greater than our card are played or not. So if they are actually played, so not played, not played. If they are not played, so in that case, actually not played, then they can place that card, and we can lose. So in that case, we return false. So that's actually is card for winner suite. So then if the card is winner for that suite, then we can place the card. So, okay, so let's do something like this. First of all, if our suite cards size is 0, which means we need to block the suite. So in that case, we should play a spade card. So we should play a spade card, and actually we should play the largest spade card. That's actually a strategy we can do better. I don't know. Return spade cards size -1. Excuse me, get, it's not an array. So if we don't have a spade card, then what will happen? So we need also check that is empty, or we can also do something like that, is empty. If it is not empty, we play a card. Otherwise, we play a random card. So we can write a play random in that case. So in that case, let's put this play random in players. So card play random. So let's put it here. So that turn play random, first player, suite broken, followed suite. So then we play random. Turn play random, first player, suite broken, and followed suite. Okay, so if the seed cards is empty, if the spade cards is not empty, we return the largest spade at hand, and then otherwise we play random. We can also put always this play random here. So if the suit card is not empty, and in that case, which means we can, if there is a winner card for the suite, which means suite cards get suite cards size -1. If it is winner, so let's make a possible winner card. Possible winner card. If it is a possible winner card, we will return the possible winner card. If we don't have a possible winner card, then in that case, a good strategy will be to play the smallest card. So in that case, return suite cards get 0. Okay, so which in that case, we don't need this. Okay, we have almost completed, hopefully. So let's reboot the project. And we need to actually debug this. So it's not so easy to debug. So we actually debug the part. We may sometimes wait infinitely. So let's see what will happen. So, okay, we have Oljai, we have 0, and we give the bit. Let's give a small bit or large bit, it doesn't matter. So let's play, for example, a diamond, winner diamond. So if we have a winner diamond, then what will they play? Okay, so they actually played king and queen. Why they did play king and queen? Because they saw that ace is played, so their king is actually a winner card. So in that case, that's a problem. So let's solve that problem. So when we play an ace, the plate is actually at hand. So in that case, we should also consider that. So let's go to the average player. So we need actually when the card is played, when the card is played, so we need to check. So since it's played, so we modified it actually to true. So in that case, if we modified it to the true, then the play card will know that it's a winner card for suite. So what can we do? There are alternatives. One alternative coming to my mind is okay, not modifying the card plate until the end of the turn, so that it will wait. That's a possibility. So in that case, when the index of the card is 4, then we update every played card. That's actually a possible strategy. So let's do like that. So private int turn count. Actually, not turn count because we already know the turn. So let's put an array list of cards played for turn. So this played for turn will be initialized here. Played for turn new array list. And then we actually add, so if the index of card is less than 4, we add played for turn add card. So if the index of the card is 4, okay, so let's always add play for turn. But if the index of card is 4, in that case, for each card, card 1, played for turn, we do this. Okay, card 1, card 1. So we add the card to the plate for turn, and then if the index for card is 4, then we do that. And then we also need to initialize, we clear plate for turn for the next turn. Okay, so what did we do? We actually created a plate for turn. So we are doing the update at the end of the turn. So that, okay. So let's see what is going on. So no problem. Let's continue. Okay, Oljai 0. Okay, enter for bit 2 and enter your card index. So in that case, let's again play the diamond. So as you see, the player played club 3, the player played ace because it has an ace. So it has a winner card. The other one plays 2 because it's smallest of its diamonds, and then the other one plays 10. So nice. Average computer 1 wins, and then it placed actually this. So the thing is, we didn't actually consider the first player case. So if we have a first player, and if it has a winner card, then it can actually play a winner card. Then otherwise it plays actually what? So let's also do that. So if you have a winner card, why not play the winner card? So in that case, if you are the first player, if you are not the first player, so let's put it here. If you are a first player, if you are not a first player, then you do this. But if you are a first player, then you can check if you have a winner card for that suite. So let's say we check if Okay, we need to know for, first of all, array list of cards, club cards. We check for the clubs. And then if we have okay, so we do something like this. If we have a winner card for the club cards, we actually return the possible winner card. So we do this for what? For diamonds and for hearts. So that's why we can put this in a function again, private card. Okay, again, do we have winner card for suite? So in that case, we give a suite. Or winner card for suite. So let's do something like this. As return null. So that's for the suite. So rename this suite cards. And then we check card, winner card for suite, clubs. If winner card is not null, return winner card. And we do this actually for diamonds and for hearts. And if we don't have that, we actually return play random. Okay, so I think now it's a little bit better. Let's do it. We can always make it better and better. But the thing is, we should stop somewhere. So let's do it here and finish here. Olcay 0. Yo, let's bid 1. Actually, very small case. So let's bid 0. And then he played average computer 3. And average computer 3 directly played an ace. So which means we are good. So what will we play for clubs? For clubs 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we play 9. And as you see, they played, and then it played a T. So why it played a T? Because it cannot play actually the ace of spades, because ace of spades is not done. It played a random number, so that's okay. Okay, so that's all for the AI part. We actually, so let's recover what we have done. So we actually have placed the play random to the player. So we have the player in the play random. And then we informed, in order to be a good player, you need to know who played which card. So therefore, in the game, we put a function to inform players. So inform players which card is played at which stage. And then we actually created an average computer player. And in the average computer player, we have a make bid, and the make bid, it counts the winning cards, which are king and ace, number of ace and kings. And if we have a short suite, so in that case, we also add this to that winning cards. And then for the play card is a little bit hard because we need to know which cards are played and etc. So we actually count the cards. So what we do is we actually count the cards. So how do we count the cards? In two phases. When the cards are sorted, we put our cards as played, as you see. And then when a new card is played at a turn, we don't put it, because if we put it, then we got some trouble as you have seen. So after the turn is finished with the fourth card, we put all cards to the cards played as played. So, and then we also clear the plate for turn. And then for the play card, if we remember the cards to play, what we do. So there are two options if we are a first player or not. If we are a first player, we check if we have a winner card for clubs, diamonds, or hearts. If we have, then we return that winner card. Otherwise, we play randomly. So in that case, what is a winner card? A winner card is the best card currently not played. So if we have that card, we play it. If we don't have, then we don't play it. Okay. So then if you are not first player, you should consider the follow suite. So we get cards for that suite. And then we check if the suite card is empty or not. If it is empty, then we check if the spades card is empty or not. If we have spades, then we play the largest spade. Okay. If we don't, we play randomly. So then for the suite cards, if they are not empty, then we check if there is a possible winner card. If we have a possible winner card, we return that possible winner card. Otherwise, we return the zeroed card. So that's actually, we can also call here as... Okay, so we can actually do something like this, but okay, not too much. Okay, that's all for AI.